I'm Hsiu from the Mobile Vision team. And then today I would like to take a code deep dive to talk about how to use Mobile Vision API to build an application that can see your surrounding. So our team mission is about bringing you the latest and greatest computer vision algorithm and machine learning that can run privately on your device with no internet requirement. We work really hard, so our API works for both Android and iOS. So now let's take a look how it works for barcode, text, and face API together in a demo application. So what you just saw was a demo application that used the barcode API to take from a product page to a web application immediately. And then it used the face API to allow the user to try the sunglasses virtually. And lastly, it used the text API to do a quick credit card scanning so it can immediately purchase the product. So Mobile Vision API is very popular. We have 125 million 30-day active users that is contributed across more than 15,000 applications. We have seen some very interesting examples from our community. For example, for the barcode API, we see applications like a wedding registry, as well as a scan barcode and a bring up price comparison for different stores. For face API, we have seen Q add-on like Vomit Rainbow, as well as facial enhancement applications that kind of like using for plastic surgeon. And for text API, we have seen translator type of app, as well as a quick payment app like we just showed in the video. So after this session, you can join our activity community to build an app that can see your surrounding. So the Mobile Vision API consists of 4 major components: the Common Utility API and 3 specialized detection API. The Common Utility API provides infrastructure and building blocks to help construct a camera streaming pipeline. The Face API can detect faces. It will report back facial landmarks like eyes and nose, as well as classification. Is the eye open, closed? Is the person smiling? The barcode API can decode 1D and 2D barcodes in multiple formats and any orientation at the same time. For the text API, it can understand all the Latin-based languages. Once it understands language, it also can report back about the structure of the text it has seen. So before we dive into code examples, I want to talk about some basic concepts. The API works for both static image as well as the pipeline, like for streaming through the camera. The simplest use case for detection is calling the detection directly by providing with a static image. The Mobile Vision API also provides the building blocks for easy configuration pipelines. So the pipeline uses a camera API to streaming the camera frame to a detector, and the detector understands it and produces detection results. Detection results then is given through a processor. A processor is like a first step of post-processing. It takes the detection results, it might discard, merge, or hand over the detection result to a tracker. So a tracker is like an event-based listener. It will receive a detection result and its updates over time. So all the boxes here in TL color are provided by the Mobile Vision API, and then you only need to implement tracker. Tracker is where you want to put your business logic. So now you understand the basics. Let's take a co-example through the barcode API. So the barcode API may sound boring, but it's actually surprisingly awesome. If you think about it, barcodes is everywhere. It tracks almost everything we purchase, including the cookies you might eat today, and then the tickets, the event ticket that you just purchased. So the Android barcode API is provided through Google Play service. You want to declare your compile dependency in the Gradle file, and then during your run dependency, you want to specify you want barcode in your manifest file. So for Mobile Vision API provided through Google Play service, it will require to download additional data package only for the first time you're using on a device. Once after it finished downloaded, you no longer require internet whatsoever. And then by specifying this inside your manifest file, the OS will know to download it before you even launch your application. So this is what it looks like for a static image case. First, you want to instantiate a barcode detector through a builder. You can specify different configuration, such as what kind of barcode are you looking for. In this example, we're looking for anything that's QR code or UPCA. With this configuration, if you see anything other formats, you will just ignore it. Next, you provide with the image to get barcodes back. Once you get barcode back, you can access all the detailed information. So here I just list some of the information, but there's more. For example, corner points is where the barcode is located on the image. And then the formats you just detected. What is the raw value it's decoded inside this barcode? For 2D barcodes, it can contain structured data. In this example, we're using phone, but you also have contacts, a business card, and a lot of other type. So you want to check it, and then once you check it, you can access more detailed information. So now that you understand how to use it with a static image, let's take it further, expand on it to using a pipeline. So Mobile Vision API provides a lot of building blocks for you. Therefore, it's surprisingly easy to use a camera string pipeline. There are only 4 steps. It's quite easy. First, you want to instantiate a detector, just like we talked about in previous slide. Next, you want to instantiate a camera source that's provided by the API, and then hook it up with the detector. With this configuration, once you say start, the camera frame will start streaming from the camera directly to your detector. Next, remember we talked about tracker is where you want to implement your business logic. It's an event-based listener with some of the methods you can override. So I just want to talk about them briefly, and then we'll take a look at a co-example. So a new item is called only when you see a detection item for the lifetime of that detection item. So for example, in the video, we saw a barcode API. This is where you want to add that graphic to your view hierarchy. Next is onUpdate. OnUpdate is called on almost every single camera frame to update you with the barcode information. So is it missing, changing shape, things like that. Missing is called if such a barcode is no longer available for certain times. It might due to it move outside of your camera frame, or it got occluded temporarily. So if it still cannot detect it over several frames, you are called undone, which is tell you this barcode is no longer visible. We're going to discard all the resources we're using for this barcode. Okay, so last is you want to specify a processor. A processor is the first step of post-processing. It takes the detection results, and then you want to hand it over to the tracker. So this is how you do it. The Mobile Vision API provides several different processors. One of them is called focusing processor, which is what is this look like. So an implementation may look like this, for example. So what it does is that the focusing processor will call select a focus to select one item to focus on. And then you will continue to deliver updates on this one. And then once the undone is called on this particular detection item, Then select a focus while call again to select the next item you want to focus on. So for example, in this focusing processor, it basically selects the largest barcode that at the time that you see, and it will focus on it until this barcode no longer exists. Even during consecutive frame, this barcode is no longer the largest. That's the one you will focus on. So there you go, 4 easy steps to use a camera pipeline. You want to specify camera source that will allow the camera friend to give it to the barcode detector. The barcode detector will run detection and then hand it over the processor. Because you are using the largest barcode processor, you will select the largest barcode to focus on and then deliver that result to your tracker where you implement your business logic. So the barcode API also available on iOS. Our iOS and Android API runs on the same algorithm. So you will get consistent result across both platforms. The iOS API is available through CocoaPods. You want to specify your dependency inside your pod file. So if you're just interested at the barcode detector, you only need the barcode detector pod. If you also want to use the pipeline portion, then you want to specify any data output pod as well. Okay, this is what it looks like on static image use cases for iOS. Very similar to our Android API. You want to instantiate a barcode detector using a factory method on GMV detector. Specify you want a barcode. Next, you want to provide it with the image to get barcodes back. And then, just like Android API, all the informations that you can access are available here, such as corner points where it exists on the image, formats, the raw value, its encoding, as well as the 2D structured data. So here's why you configure a pipeline in iOS. It's still the same 4 easy steps. However, we did make some changes so it respects the iOS convention. First, instead of a processor, we switch it to a data output, which is the iOS native component. And then instead of camera source, we're using a native AV capture session that streams the camera. So rest is very similar. You want to specify a detector. You want to specify a tracker where you put your business logic, and that you are using the largest barcode focusing data output instead of the processor, and then you're streaming the camera pipeline using the session. So now let's talk about Face API. So Face API can detect faces. It understands landmarks like eyes and nose, as well as classifications, like eyes closed open, or is the person smiling. One thing to note is the Face API is doing detection, not recognition. What that means is that the Face API understands there is a face exists in an image, but it does not understand who is it in the image. So the Face API is quite resilient. It can detect faces with extreme expressions, different angles of the face, as well when there's occlusions happening on the face. Just like the barcode API, the Android API is also provided through Google Play service. You want to making sure you declare face as your manifest file dependency. So this is what the API look like for a static image use case. You want to instantiate a face detector using a builder, and here's all the different configurations you can use. You may want to return landmarks information, classification information, or specify what's the smallest size you are interested in. All those different configurations have different trade-offs between speed and accuracy. So you want to choose the best that fits your use cases. Next, you want to provide it with a static image to get faces back. And then you can access all the face details just like before. So this is what a single face tracking might look like. It's just the same. You instantiate the detector, you instantiate the tracker, you use the processor to route the detection through a tracker, and then you use the camera source to streaming the frame. So we talked about the focusing processor before. Now let's take a look about what a tracker implementation may look like. So this might be the sunglasses tracker that you see kind of like in our demo. And on new item, you want to add your sunglasses to your view hierarchy. And you want to override the onUpdate to update where that graphic is so it moves with your faces. So far we have only seen how to track one detections item. What if you want to track multiple items? We provide something called multi-processor to do just that. So instead of the focusing processor, you want to use the multi-processor. And then inside, it will understand to initiate the tracker. And then you will immediately start tracking multiple faces instead of one. So this is what multi-processor works. It understands when it sees a new face, and you will instantiate a tracker immediately and associate that face with the tracker. So then when you continue to get update, it will only update to that particular tracker. Again, the Face API is also available for iOS. For your CocoaPods, you want to specify face detector dependency. This is what the static image looks like. You want to instantiate your detector through a factory method and a specify face. Pump it through with the image, and then you can access all the information just like in the Android API. So this is what a single face tracking looks like, very similar to the barcode example we just gave earlier. And then this is what the tracker may look like. Very similar to Android, there's two methods you want to override. One is the detected feature, which is called when it sees a new face for the first time. The update focusing feature function is called when the face is moving around and you will receive updates so you can update your graphics. Just like the Android API, we also support multiple trackings inside iOS. Instead of using the focusing data output, you want to use the multi-data output. And then the changes you need here highlighted. Text API. So Text API can understand any Latin-based languages. Oops. Let me go back. It understands different font sizes. It can understand, detects different text colors as well as different text background colors, kind of like here shown inside the video. Okay. Once it understands it, it also can report you about the text structure. So the structure breaks down is like this. Roughly speaking, a paragraph is referenced as a blocks. Inside a blocks, it may contain multiple lines. Here is the mapping. And then within each line, it understands words, which is the smallest unit it understands. It's also provided through the Play service, and then you want to specify text as your dependency in your manifest file. This is what a static case going to look like. You want to specify instantiate text recognizer through Builder. And then you may see there's no configuration option on our text recognizer. You want to give it a static image to get text back. And then here you can specify languages, bounding box, which is where is it, the raw value, as well as the structure information like lines and words. This is what a text pipeline may look like. There you have it. In summary, there are 3 specialized detectors for Mobile Vision API. The Face API that understands face, and then can report you back on facial landmarks like eyes and nose, as well as classification information. Barcode API understands 1D and 2D barcodes. It can detect multiple formats in different orientation at the same time. The Text API can understand all the Latin-based languages, and then can report you back with the structure. And then they all work as well with our common utility API, which provide you with a pipeline structure. So now, so all the stuff I have talked about is available here in the Mobile Vision the developers.google.com/vision website. Specifically, I want to point out there are collabs that you can follow step-by-step tutorial. And then there are samples you can play with for both Android and the iOS. We follow our Stack Overflow questions very closely. So if you have Android questions, you want to use Android-Vision tag. And then for iOS question, you want to use Google-iOS-vision tag. So here's some labs. I want to talk about a little bit tricks and tips to how to use our API. First, always run your detector in the background thread. So this is not just applied to the mobile vision API, but it also applies to pretty much all the machine learning models. Because each model can roughly run from 60 milliseconds all the way to more than 300 milliseconds. So you always want to run them in the background thread, so your UI is very smooth. Next, you want to do some imaging pre-processing before you provide the image to the detector. Because the detector can be expensive, so you want to filter out stuff that's kind of blur. And then in the camera, Android Camera 2 API, there's a blur score you can use. And then if you don't have that, what you can do, you can use a gyroscope angular structure and then expect that over time to calculate a quick blur score to detect. And you only want to provide sharp and nice images to a detection algorithm to save you some time. Next, the API is kind of limited. What can you get more value out of? So the answer is you want to use it as a pre-processing for other stuff. For example, Cloud Vision API can provide you even more information for classification, such as anger, estimate age, or gender. But it's very expensive to make this round trip, right, from your device all the way to the cloud. So what you can do is you can use the mobile vision API to run through the frame to making sure there's a face and predominant for certain size over the frame. And then you deem that as a good frame before you send it to the Cloud Vision API to reduce the latency of your application. There you go. That's my talk. And I'll be at the Ask a Speaker zone after this for 20 minutes. So please come and feel free to ask me questions. Thank you.